So I think I'm probably coming at the right time after you talked about lecture on the whole world of JavaScript. And I've got 10 minutes, so this is going to be really fast. And yes, the title and the whole institute that I work for might be mouthful, but that's not why I'm here. I like to still think I am a developer. I did my PhD back at the School of Computing at Leeds, but I'll try to be kind of reconnected with you guys rather than with the researchers who really are forced to kind of code than we are and we love to do. So the team is the research funding comes from Alan Turing Institute. They were based in London. If people want to find out more about them, kind of the National Institute for AI and Data Science, and funded heavily by the UK government. But Dr. Nick Lomax, who's a geographer, Roger Beecham, who loves visualization and he does awesome visualization, are both at the Earth and Environment at Leeds, and I'm the programmer, the coder. But I didn't do JavaScript. Seriously, I was not taught JavaScript at School of Computing. Back in 2004, it was like, JavaScript is dangerous. Why would you want to do JavaScript? We've got HTML5 and the whole story, basically. So every time I want to talk about JavaScript, I'm kind of in the still defending mode and saying, come on, it's not about Rust. JavaScript can do quite a lot. So I found myself, after my PhD, handling a large-scale project that needed a scalable front end, and hence my story of JavaScript, because I had to find out something better than jQuery, and then the story starts, basically. So a couple of quotes here, but I'm going to skip because Nathaniel just really covered most of it, really. Here is a story from the man himself, but I think for what I'm doing, the reason that I had to dive back into JavaScript, and I was supposed to do R and Python and stuff like that, is because we now can use WebGL. When I did my PhD, I had to rely on iOS's graphics library, basically, and I couldn't do the WebGL back then. But now we basically run on top of the GPU. We've got TensorFlow, thanks Google. We've got quite a lot more, and my recent trip to Vancouver, I found out that basically the best paper won because it was a web app, because it was written in JavaScript, and I'll show you that a little bit. So the thing again covered all sorts of space that JavaScript has taken, and the mobile world, that's where I started really doing Android first, and then iOS a little bit, and then had to obviously switch over to React Native again for that graph databases project. Again, back to your 1994. So here is, and putting you back into context, what I'm doing currently is web mapping, lots of geospatial visualization, so a bit of history of web mapping, hence this beautiful image. But the libraries that we can use are as big as these, really. So many of them. We're going to focus a little bit, well, I'm just going to highlight, really, I'm not going to talk about them, OpenLayers and Leaflet, and basically the Mapbox guys hired the developer of Leaflet JS, and he works for Mapbox, and Mapbox basically just is amazing. And just I should stop a little bit there because Uber guys have been also working quite hard to add layers on top of Mapbox to visualize their own data, and they've got an API to release parts of the trips data, which again, if I have time, we can have a look at a beautiful isochrone of trips around Leeds. This is the best data viz paper from IEEE Viz this year, Vancouver. It is actually beautiful, and I loved it. The idea is very simple. We can have a look at it actually, but we can have a look at it really. It's just a demo of the application. The source code is available. You just remember VizFlow or FlowSense if you like. But best paper IEEE Viz 2009. My slides are available anyways. You load the library, an icon for the library, data set that is, and they've got few for you to play with. MPG and Iris dataset and stuff. As you do that, that's the library hidden there, and then you load, for example, a scatter plot. As you do that, you just pull a line from the dataset to the scatter plot, and here you assign your values, basically the x and y, and magic happens basically. This is our work. This is I started this back last year. Who has heard of Uber's Kepler-GL? Yes. Okay. So quite similar to Kepler-GL. Kepler-GL is again one of Uber's progressive or incremental work from their DeckGL library, which is an interface to analyze geospatial data, basically, the way I've done it. I've taken a slightly different basically turn from Kepler. I could probably still go back to Kepler and make it the base of the code, but we just wanted so much customization that I thought probably I would be tinkering too much with Kepler than writing my own code. So we started with it. I started with this. This is, and hopefully show you a little bit if I've got still time. And I'd love to touch on that on that stack a little bit if I have time. But here is our current work. This is the local host one. There is an IP address. Alan Turing Institute will assign a subdomain to it, but I'm going to discourage you from having a look at this, but it is somewhere available. So if I reset this back, we will be loading, and I should change the map back to the default. This is Department for Transport's Stats 19 data. Anybody heard of? Road crashes are recorded by police officers, sent to the Department of Transport. Department of Transport processes that and releases it back to the public domain, as with all sorts of other departments around the government. This is the chunk in our area. I've clipped it off just to show you. What you see, the heat map here is, again, Uber's DeckGL, just superimposed on Mapbox. So the tiles here, and then what I have done is written React modules to be able to then generate visualizations as you explore your dataset. For example, if we want to just see the same, we've got another one for the road types, but if we just select the road type and say, can we have a tree map of those, it should be able to generate a tree map, and you would see that, yes, single carriageways cover the most of the dataset, for example. But again, you could change the way you look at the data, and again, we could be going on about this for long, really, but that you probably get the idea. And what we try also to do is to be able to load your own, hopefully different types of data sets, because there are libraries, again, JavaScript amazing, that you could that it could detect a CSV being location columns within it and converting it into the type of, obviously, format that Mapbox and Leaflet and others would be able to process it. So quickly, if I can, I'm not sure if I've still got time, if we dump a little bit of area or region data, this is again data generated by my colleagues, again Nick, who has done it. We would be able to we should be able to. So this is the areas of I think around Oxford, where they've predicted GVA and a couple of other variables, which can be seen again in the variables here. That we can assign the way we color the choropleths, or indeed, as with DeckGL provides it, with the height of these areas according to the GVA or the jobs predicted up to year 2050. This is incredibly, obviously, customized still to the datasets that I'm aware of. When you upload a dataset that it knows nothing about, the only place where I have managed to get it to work is similar to Kepler-GL, again, one person in the back knows about it. You can explore your data set based on that, and also the type of visualization you superimpose on the map can be based on that column that you can choose. I think I should stop here. Okay, cool. Finally, you can find me on GitHub. If you search for Layik, you should get to the repo and everything else that I just presented.